started it / attempted it. No. There are Band-Aids back there whenever you need them. But we are, no, I'm not going to get you a Band-Aid. You are a senior in high school. 3 minutes into class and you haven't even started that. Come on. If you need a Band-Aid, go get one. Did anyone not get the understanding check back because they didn't do it? I think everyone here did it.
I got a question.
We will go over parts of the understanding check. I need you to focus on doing the bell ringers, and I'll answer some questions during that discussion. Okay?
What gave me a bigger one?
I didn't give you anything. You earned.
It'd be right here. I don't see.
You said it's number 5.
That's what we get. What can you say?
Okay. Yeah, this coordinator must have just missed that detail. So give that back to me, and we'll update that. Okay.
What day is this?
Today is the 26th.
Sorry.
Yeah, there is a few.
Oh, my bad.
Thought you was smart as anything.
This is very wrong.
Cap me down.
4.5. Look again with that question. See
Yeah.
Okay, so we can
what does it say?
Not
At the top. Right here. Okay. What does that say? Does it say solve? Did you factor?
So.
You got lucky on those. I would score that bus.
You're right.
Okay, just give that back to you. And I forgot to score it. I must have not had it separated off to the side. Yeah. Apparently on this hers, I think it must have been off to the side. So I got those. So if you can give her feedback really quickly. Mackenzie, right now it'll be easier in the grade book until I get it scanned, so give it back to me at the end of the class so I can take a scan of it. But bring it back to me so I can, or give it to me at the end of class so I can do a scan, okay?
what do you try to do? It sound like E40 when you talking fast.
Apparently I put a marker in there again. And didn't have a catch.
Again.
Oh, 1 second, I'm checking attendance. David, were you taking little pictures? Guys, Why has no one submitted an answer for the bell ringer? It's been 7 minutes.
Trying to figure it out. Kind of rushed.
No.
Miss Ken, what's going on with your pen?
I put a marker in my pen so that it's hot on. Yeah. It was a bummer. Guys, 7 minutes is not how long it should take to factor that. You have small groups to talk with, you have work that you can be doing. Oh, and I need to take those down. Did you look at the back side too?
You can swap them. Switch them around.
Okay, I know why.
Like you can put it in two.
Yeah, and I'll move around. I know I something I don't.
So you know how to do it, smart one.
I got 6.
I got a 6. We can.
Alright guys, you'll have like 60 more seconds until I'm done looking at this, and then I will. Tyrese, did you had scores on?
It was just one.
It was just the one? Oh, that's right.
I didn't realize it was right on the bottom.
I got the rainbows on.
All right. Stop the poll, we're going over it. So the most common answers, we have quite a few who actually said 2x minus 3 times 2x plus 5. In fact, all of these students said the same thing. Here, what did some students try to do? They try to put it in vertex form. Is that what it's asked for?
No, sir.
No, it's asked for what?
Factor.
Factored form. And I need y'all to pay attention to us going over this problem because there's 2 super important things that we need to learn out of this. Overall, I'm going to move a little bit quicker through the AC method of the actual factoring. If you have a question, please throw that hand up, say, hey, Mr. Kinney, whatever, so we can go over that question. But when we're talking about the AC method, why is it called AC method?
Because you multiply A times C.
You multiply A times C. And so we get, not 16, I don't know where I got that from. 4 times negative 15 is negative 60. And we need factors of that do what?
Add up to 4.
Add up to 4. And I want to remind you, you can very easily see those factors right away. But if you don't, that's also okay. KT, Tyrese, I need those headphones up, please. If you do not see those factors right away, start at the most basic level. 1 times 60. But don't forget, if it's 1 times 60, is that negative 60? No, one of them needs to be negative, and that means one of them is positive. You can find that out here right away. Which one is positive and which one is negative?
The big one's supposed to be positive.
The big one's supposed to be positive. The only way we get a plus 4x is if the bigger number is positive, meaning the smaller number is negative. That doesn't add to 4. That doesn't add to 4. And notice I just keep going through, and if you're not sure what the other factor would be, you just divide, right? Negative 60 divided by negative 3 is that 20 that we have right here. Negative 4 and 15, still doesn't work. Negative 5 and 12, that's a 7, not a 4. So negative 6 and 10. And so remember, we then split up that middle term into those two factors, or into those two terms. So the 4x is equivalent to negative 6x plus 10x. Questions, comments, concerns up to this point?
No, sir.
Feeling okay? Then remember we factor by grouping. What do 4x squared and 6x have in common? 2x. If I factor out that 2x, what am I left with? 2. Remember, I only factored out a 2, so I still have the 2, and I still have an x. Minus what? 3. Plus? GCF here? 5. So I pull out that 5. Actually, I'm going to leave this off for a second because I want to point something out. 5, and then what am I left with? 3, right? 5 times 3 is 15. We need to pay attention here. This is something I saw a lot of students do. But if you don't write anything in between here, what's that implying? Multiplying. Are we multiplying this by that? If you factor out, there needs to either be a plus or a minus. And it depends on whether you factor out a positive or whether you factor out a negative. So we want to notice that we factored out a positive 5, so we are adding 5 times blank. Pay attention to that. And then we need the 2x minus 3's to be the same. We need the binomial that's there the same. If they're not the same, you can't take this next step. If they're not the same, either you made a mistake or maybe it's just not factorable. But because the 2x minus 3's are the same, I factor that out, right? So I divide it out. And if I factor out that 2x minus 3, I'm left with 2x plus 5. Do not forget, this was on the calculator portion of the test. How could you have checked? Graph what? I hear a couple of y'all saying close to it, but I can't fully hear you. What did you say? Graph that standard form, graph that vertex. No. Which form? Factored form, right? That you maybe you said factored, I'm just mishearing things. It happens. So here they are. Notice, there's my factored form. There's my standard form. How many graphs do you see right now? 1, because they are mapping to each other, which means they are equivalent. Check yourself. Show me what you can do if you mess up, but you graph them and notice you messed up. Tell me that. That's perfectly fine. Now, I need you all to look at this because this is the most disturbing detail for a lot of us that we need to learn from. Oops, that's not what I want. Here, y'all have factored it. But I saw a lot of us in this class who had their final answer as x equals 3 halves and the x equals negative 5 halves. And that's very much wrong. Does anyone know why? Those are the zeros. Did I ever ask you to find zeros?
No.
Did I ever ask you to solve the equation? Do you know why we should have known right away that you couldn't solve an equation with this one? There's no equal sign. Can you just magically put in an equal sign?
No.
No. What did the directions ask?
Factor the following.
Factor the following expressions. That was it. Please note that to yourself. If you tried to continue to solve, there was not an equation to solve. This was just factoring. Please make sure you pay attention to that. There were no equal signs. There was nothing else to do besides factor. What are your questions, comments, or concerns at this point? Do we understand how to fix that if we did make that mistake? Okay. So again, please note and make sure you pay attention. If there's not an equal sign, you can't magically make an equal sign. You're just being asked to factor. Pay attention to the details. They matter significantly. Okay, we're going to go more over that understanding check to start today. So a couple of details from the understanding check. Things that we noticed that we need to address, especially number 9. I know there was a lot there. Please be aware that we will have that next understanding check on Thursday, 2 days from today, to help make sure that we are ready for the test. There was something else I want to say with that. Oh, we're not going over everything. Miss Courtney scored these and gave you all feedback. If you need more feedback, give it back to me and I'll look and see what I can give you. Tell me which problems you want us to give you extra feedback on. But we're going to go over some of these things right now, so make sure you take notes. Also, I need you to remember, these scores are not just scores. It's not just, hey, you got a 4 or just got a 4.5. Realistically, when you're taking an understanding check and when you get an understanding check back, you should have out your lime green scoring rubric. If you need a new copy of it, cool, but you need to let me know that, because this is what we use to score and it also gives you information. If you have a 4, that's not a bad score, but that does tell you that I see limited evidence of your understanding. And you need to be aware of that, because that's something you need to learn from and improve your understanding. Mackenzie, I need you to put away that graphic organizer and do that at home or during enrichment. I need us to focus on learning right now. Right? If it's a P, C, or D, you need to pay attention to that so that you know, hey, is it just a procedural thing? I made a mistake doing the work. Is it a C, a conceptual error? Because if it's a conceptual error, that's something that's going to come back to bite you over and over and over again, because you're misunderstanding something. Is it just a D, that you are missing some details when it comes to your justification? All of those make a difference, okay? And so pay attention to the amount of evidence that you're showing us in your understanding and what those numbers mean. Don't just look overall, oh, I have 3 5.5s and a 2, so I'm good to go. No, if you have a 2, that's something you need to investigate because there's an error in your understanding, or you're really far off. Pay attention to each of those things. Same thing with the graphic organizers. So let's look at lesson 6. One thing I want to point out here, and I'm not going to write this on the board, so you need to write this down if you don't have this. If you cannot factor a quadratic to solve, that's only one method to solve a quadratic. What are the other methods that you could use to solve a quadratic? By the way, this is on the white sheet, right? The non-calculator portion. And this is where I saw a lot of details being missed. So you can convert the standard form to vertex form. But you can't just say convert it to vertex form. Once you convert it to vertex form, what do you need to do? But how are we going to solve from vertex form? Because so I want to pause, I want to remind you, we've already said that we have the vertex form. Yeah, you're going to graph, you're going to get the vertex. But once you get the vertex form, once you get something like, I'll just write over here, x minus 2 squared plus 1 equals 0, you have vertex form. How are you going to solve that? You're going to use inverses. And what else? Yes, but there's something more important. So remember, I already said inverses. That covers square root. No, we only use zero product property when factoring. Thank you. Properties of equality, right? If you use an inverse, whatever you do to one side of the equation, you got to do to the other, right? So if you get vertex form, if you didn't already have that detail down, you can convert to vertex form and then use inverses and properties of equality. That is a great method. That's the one you already had. Notice, though, do you have the detail about using inverses and properties of equality? Guys, you cannot just say, hey, I'm going to write down vertex form. You're going to convert to vertex form and then use your inverses and properties of equality.
Yes, sir.
Okay. What's another method you can use? Quadratic formula, but there are stipulations to it. When can you use quadratic formula? Close, so part of it, but it's not just standard form. There's something special about that standard form. It has to equal something. 0, right? So we have to be clear about that detail. If you're using quadratic formula, the standard form has to equal 0. And there's one last method, the easiest method. Huh? Graph it. What are you going to look for when you graph it though?
Vertex.
Not the vertex. The vertex is going to help you get vertex form. You're looking for what? Zeros. Remember, your zeros are your roots. Those are the solutions. Now, one thing to clarify is the quadratic has to equal what for you to look for zeros? 0, right? So it's important to remember if you're going to graph that function and look for zeros, the function has to equal 0, or the equation has to equal 0. So notice throughout all of these, there's only one that you don't have to, so in general I'm going to tell you, make sure the equation equals what? 0. Don't forget that. Questions, comments, or concerns up to this point? Okay. So we already did number 5 here. Once again, we do want to pay attention to on this up here that, is it equal to 0? Are we solving? No? Make sure you show me the details of A times C. And work through this one because we've already done one very similar to this, right? I need -2 and -10. So x squared minus 2x minus 10x plus 20.
It's on the understanding check.
This is a blue one, number 4. Yep, calculator portion. I know I made a mistake, it's okay, I'm stopping here for a second. What mistake have I made currently? Well, that's not actually the mistake I made, I had to do +2 because what did I factor out?
Yeah, -8.
I factored out a positive 10. If I just factor out a 10, wouldn't I be left with -x and +2? So mathematically, what I did is correct. However, the issue that y'all are noting is that, are these binomials the same? No. So we do want to pay attention to that, right? We need our binomials to be the same. So instead of factoring out a positive 10, what should I have factored out? -10. So I'm going to take the opposite here, which means I need the opposite over here. So it's not a -x, it's a positive x. It's not a positive 2, it's a... Now, because I have common factors, I can factor out my x minus 2, and I would be left with x minus 10. Okay? That should be your factored form there. Once again, I need you to remember it needs to be a +10 or a -10. You can't just put a 10 there. Okay? We already did number 5. What are your questions here before I continue? I think we're a little bit stronger in this class, so I'm not going to spend forever on these. We good? Okay. So I'm going to look here at number 9 at this point. Do you know what the most common mistake on A, B, and C here for number 9 was?
No, sir.
It's the same mistake on both A and B. No, they tried to solve it. We're okay on the method. Look at A and B. What's the issue there? Okay. A lot of us tried to factor here, which this is the one that you can factor on. And we couldn't factor it because right now you can't. We tried to identify A, B, and C here to use the quadratic formula, but you can't use the quadratic formula here because of what is it not equal to? 0. You have to make sure it's equal to 0 to use quadratic formula, to graph and identify the roots, or to factor. So what can I do here to make sure it's equal to 0? Not properties of equality. Well, I'm going to use that with what? Notice, I saw some of us adding 2 here, and if we follow that, we get 2x squared minus, don't write this down, minus 7x, that creates a 0 equals 4. Does that make it equal to 0?
No.
No, because I didn't want the additive inverse here, I wanted it with that 2, so minus 2, I get 2x squared minus 7x minus 4 is equal to 0. Note now, when you do 2 times -4 and you get -8, are there any factors in -8 that add up to -7?
8 times 1.
Close. -8 times a positive 1. But remember, KT, that's important, right? Because if I do 8 and 1, That adds up to 9. It also doesn't multiply to negative 8. I need to add up to negative 7. Now, the other way is easier to factor. If you factored it, if you put negative 8x plus x, you do want to note these details, right? So there's a 2x in common here, so x minus 4. What do x and minus 4 have in common? Nothing, but that does mean we have a factor of 1. Everything has a factor of 1. So what I can do is I can write plus 1 times x minus 4. So if they don't have anything in common, I can still factor out a 1, and then I can factor from there. They both have an x minus 4 times 2x plus 1 equals 0. So I understand why some of us try to use vertex form or things like that, but we need to note where we might have gone wrong with this so that we can improve our understanding. I will say I wouldn't have used vertex form on this one because I already know if you graph it, you would have gotten a decimal for your vertex. So I would not have used vertex form here. I would have used factor or graph or quadratic formula. Okay. Questions, comments, concerns through this point? Now, at this point, you should recognize what is the next step I'm going to write.
X minus 4. Again, 2
Equals 0.
2x plus 1 equals 0.
Do not forget, though, you need to justify your claims. What in the world is the reason that I can go from this step with 1 equation to this step with 2 equations? You got to identify that. That's a part of your justification that has to show up there. That's again why with factoring, we need the equation equal to 0 so that I can use that zero product property. If it's not equal to 0, you can't use the zero product property. So I'm not showing the last steps, but if you solve it out from here, those are the solutions. So I'll point this out with B. Anybody have an idea how I'm going to solve this one? Well, first off, what do I need to do with B first?
Set it equal to 0.
Okay. So, but what do I need to do to make it equal to 0? Okay, minus 3, and then with that minus 3, a property of equality. Before I even do any work, I already know which methods I want to use here. I know which ones I don't want to use.
Which ones are those?
Which ones I not want to use?
Yeah.
Factoring. I've already used factoring. 1, 2. Why do I not want to factor here? It's got that decimal. I'm not factoring that. No sir, no way, no how. Do I want to use vertex form? Probably not, because what do I have? Decimals, right? I'm not going to use vertex form here, which leaves me with which 2 options? Quadratic formula and graphing to find the roots or zeros, right? I've got it equal to 0, so I can graph it and find those zeros. But personally, just because, again, graphing is the easiest, you just identify those zeros, you're good. I'm going to use quadratic formula here to at least set it up. Now, what is the quadratic formula?
Divided by 2 times 8.
Divided by 2 times 8. Don't forget its division. We want to be careful with that language. You got to know that equation. It's not terrible. Spend a little bit of time with it. It sticks. Okay, so make sure you're studying it, and you'll be okay. So in order to use that equation, what do I need to identify?
B.
What is B?
3.
What is A?
1.7.
Be careful. That negative matters. It will change things. C?
2.
2. Okay? Again, if you just put stuff in the equation, I may miss where you make a mistake. if you identify A, B, and C, and I see that you made a mistake identifying A, B, and C, but everything else afterwards is correct, you can still earn a 5P. Because you made a small procedural error just identifying A, B, and C, but everything else is right. That's why I need you to show me your reasoning and show me how you got there, because just misidentifying A, B, or C, that's not that big a deal. Understanding how to use a quadratic formula, understanding it's got to equal 0, that is a big deal. Okay, so x equals -3 plus or minus square root of 3 squared minus 4 times -1.7 times 2, all divided by 2 times -1.7. Be careful. Make sure, personally, I would just put all of this. Does anyone remember what we call this thing under the radical? Radicand, right? We talked about that yesterday. I would substitute everything from the radicand into the calculator and just use the calculator to help simplify it if I were you. Okay? But then eventually, do not forget how many solutions are we supposed to get? 2. So I need one that's adding and one that is subtracting. Do not forget that. Okay? So one that is adding, one that is subtracting. But from there, it's just putting into a calculator and letting the calculator do the work. Okay? So what methods do we have left for C? Graphing to find the roots, or the zeros, right? Or I could use the vertex form. What is the vertex for C? You're not going to be able to see it up here to know the vertex. You'd have to graph it, or maybe you already have it on your paper.
-1 and -5.
The vertex for C?
1.
It's what?
Oh, okay.
-2, 1.
I thought it was it? I thought it was 2 comma
2,1.
Yeah, if you graph it, I'm pretty sure that vertex, that minimum is 2 comma 1. Right? And by the way, I already have it set up over here. I knew that one was going to come up later. Okay? So x minus 2 squared plus 1 equals 0. Now, why is there nothing written in front of this vertex form? What is understood 1? A. Right? So if I look at x squared minus 4x plus 5 equals 0, the only thing I pull directly from this equation is A. A equals 1. And so, remember, I'm going to write out my vertex form to make sure I don't make any mistakes, to justify it. Now, from here, actually one detail I want to point out. To get vertex form, you would have to graph. Right away, when you graph, we hadn't done a ton of this yet, but you know this now. There's your vertex, and it's concave up. There is no way you could have ever factored this problem just looking at this graph. Do you know why? It never intersects the x-axis.